Hi. In this second presentation in the regular sequential circuits playlist, we will look at the two-segment coding style. After watching this presentation, I hope that you will be able to write VHDL descriptions using this coding style. The standard representation of synchronous sequential circuits was shown on the top right of this slide for the basic D-type flip-flop, and also on the center of the slide for the general representation of a finite state machine, brings into evidence that the information related to the state comprises two main components. The outputs of the memory elements, which are represented here by the underscore register signals, and their inputs, which are represented by the underscore next signals. Whenever there is a rising edge in the system clock, the underscore register signals are updated with the value of the underscore next inputs. Well, to improve the clarity of VHDL descriptions and also to simplify the logic optimization during the synthesis process, it is recommendable to create two segments in the architecture body, one to describe the registers and the other one to describe the combinational logic blocks, which, as you can see in this representation, are responsible for generating the next state information and also the external outputs. This design style, separating the state segment from the combinational blocks section, is what is known as two-segment coding, and we will normally follow it in this course. Now, if we consider the simple case of the D-type flip-flop, the architecture body can be written using a two-segment coding style as shown here. The first segment contains a process to describe the 1-bit register, and the second segment contains the description of the combinational logic blocks, which in this case comprise only a multiplexer to generate the next state information and an identity function to generate the external output. As an additional example to illustrate the use of two-segment coding, we can look at the case of a simple shift register, which in this case is a shift-right register, that is to say, a block that shifts its content to the right whenever there is a clock pulse. Please notice that the state register segment in this case will set the current register outputs to 0 whenever the reset input goes high, or otherwise, if there was a rising edge in the clock signal, then the outputs of the memory elements will be updated with their next state information. So please notice that this description will be exactly the same if we are designing a counter instead of a shift register. This is one of the advantages of the two-segment coding style, because it improves clarity so much, and in fact you will see that the difference from one type of circuit to another is defined by the combinational logic segment, which in this case comprises two statements, one for the next state logic and the other one for the output logic. You may pause the video at this point and look at the next statement to understand how the shift register function is implemented. Before closing, I leave you one question, which is how would you modify this description in order to design a bidirectional shift register? Thank you for your attention.